キヤノングローバル戦略研究所研究主幹杉山大志です。本日はですね、ビョルン・ロンボルグ様をデンマークからお迎えして、気候変動問題ですね、これに関して改めて考え直してみようと、行き過ぎがあるかもしれない、効率のいいやり方があるかもしれない、そういうお話を伺います。でビョルン・ロンボルグさんはですね、コペンハーゲンコンセンサス研究所の所長ということで、おそらくですね、一番初めに気候変動問題ってそのリスクを冷静に見ようよということを統計の分析に基づいてですね、世界中に警鐘を鳴らした、そういう方だと思います。それではロンボルグ様、どうぞよろしくお願いいたします。
Thank you very much for that kind introduction, as I'm assuming it was in Japanese. So it's a pleasure to be here this afternoon, and I would love to tell you a little bit about how we should think about doing smarter climate policy. That involves a number of steps. I'm going to walk through them. You also have the slides on the table. But fundamentally, I think it is incredibly important to say, yes, global warming is a real problem. It's a man-made problem. It is something that we should tackle. But we should also recognize that currently, global warming and the way that we talk about it is often vastly exaggerated. This means it's something we should deal with, but the vast exaggeration, which I'm going to show you some of the indicators for, makes us make bad policy. That is where we really need to think smarter and better. So you have heard a lot of the claims. You hear them from all of your favorite politicians around the world. I'm just going to sort of use Guterres, who is all of our UN Secretary General, who often have very strong claims on climate change. He'll tell us the world is facing a grave climate emergency. Every week brings new climate-related devastation, floods, droughts, heat waves, wildfires, superstorms. I would argue that that's certainly how most politicians keep reinforcing that global warming is not just real, but that it really is almost the end of the world. We're in a battle for our lives, and this is also what President Joe Biden in the US will tell us. This is an existential crisis, and that climate change is the biggest threat to the global economy. Now, there are kernels of truth in this, but mostly this is vastly exaggerated. And again, that's one of the reasons why we can't have a sensible and useful conversation about how we actually think about climate change. So let me walk you through, obviously I do this in my articles and in my book, all these different claims. I'm just going to show you two of them on floods and on storms, but obviously in the questions we can go through more of them. Hurricanes have become one of the things that everybody talks about. You may remember Al Gore's movie, An Inconvenient Truth, where a storm or a hurricane comes out of the smokestack. It was a very clear example of saying climate change is directly causing more and worse hurricanes. Well, actually, if we look at the evidence, this is not what we see up till now. Now, we have a theoretical expectation that we actually will see fewer or about the same, but stronger hurricanes. And that will net be a problem because stronger is worse than fewer is better. And so there is a problem. That's why global warming is a real problem. But this is not what we see in the data so far. And again, me show you, we see a lot of data from the 1980s, partly because that's when we started having global coverage of satellites, but it also was a lull in global hurricane data, and so we inevitably see a trek upwards. I want to show you the longest good data records that we have. These are from the US, and again, remember, we see a lot of more hurricanes now because we can see them with satellites, and we have even better technology now than we just had 10 or 20 years ago. So we notice a lot more hurricanes out where there's nobody to experience them, but they just happen out in the open ocean. But if you look at hurricanes from 1900 in the US, landfalling hurricanes is very unlikely to have been ignored. So this is a good measure for looking at landfalling hurricanes. If there's a landfalling hurricane, someone would have noticed in 1900, and that's the same thing that we can notice today. So this is a very robust measure. And what that shows, and this is the best data that we have globally, shows not an increasing number of hurricanes, actually, if anything, a slight decrease in the number of hurricanes that fall on land in the US over these last 124 years, as it is. But people will argue, but stronger hurricanes, surely the hurricanes get stronger. Again, if we look at major hurricanes of category 3 and above, again, what you see is a slight decline, certainly not an increase. Again, what this tells us is what we're seeing is very much a media-driven argument, because obviously now we see stories every time there's a hurricane, and also many times when there's not really a hurricane that hurts anyone, but it just shows up on a satellite, we will see stories about that. But that, of course, is not a good indicator of what actually happens in the world. A little bit like you may know in the US, that since talk show and 24/7 news TV became popular in the 80s and 90s, there has been an inundation of the idea that there's more and more violence. There's more and more crime. There's more and more violent crime or robberies in the US. Well, actually, the FBI statistics very clearly show a decline, but you see more and more violence and crime on TV. And so every year when they ask Americans, is there more or less crime, they'll tell you there's more crime. A large majority every year will say there's more and more crime. But it's a media-driven understanding rather than the data. And I would argue that's very much what we see here with hurricanes again. It is not that there's no problem with climate change. Eventually, we will see stronger hurricanes. And that is all in all a problem. But that's not what we've seen so far. Likewise, if you look at another very, very visual thing, people will tell you a lot about wildfire and how wildfire is just exploding. We're living in a burning planet, as New York Times tells us. But actually, if you look at the data, where we have good data, so we have model data from 1900 till about 2005. This is necessary for the climate models to run. We need to know how much burnt every year. So this is not a measure, this is a reconstruction, but it's the best understanding that we have. It used to be more than 4% of the Earth's land area burnt every year. And since then, it's gone down to less than 3.5%. We've actually seen a decline. Now, obviously, since 1997 or thereabouts, we have good satellite data that covers 24/7. And what the satellite data very clearly shows is a dramatic decline. We don't actually have good data for 2023, but I put in the proxy for 2023. So we believe that what we're seeing is very clearly a decline overall in the amount of land burnt. Now, this has nothing to do with climate. This has everything to do with humans. Humans don't like fire. We actually work very hard to make sure that things don't burn. And that's why we've seen a dramatic decline. So what we're seeing as more and more fire is possibly true some places, but globally, the world burns much less. And this is mostly because of human adaptation. We need to know this. Now, what is going to happen in the future if you include human adaptation? Well, it turns out if we do nothing about climate, it will still continue to decline. But if we do climate policy, it will decline even stronger. Which tells you again that climate change policy is not necessarily a dumb thing. Climate change policy actually delivers. Cutting carbon emissions can make it burn even less. But it's an important psychological distinction. Instead of a world where that's sort of burning out of control and then we need to control this with climate policy, it's a world where we control fire ever better. But with climate policy, we can control it even better. I will get back to this because I think this is perhaps the single most important thing to get people to understand how we should think about climate. That we first need to understand that climate is not about a world spinning out of control. Climate means that the world gets better and better, slightly slower, which is a much less alarming argument than this is the end of the world. Why do we get it so wrong on climate? Well, I would argue that it's very often because we miss adaptation. So perhaps the single best indicator of how we've tackled climate change is the number of deaths from climate-related disasters, so floods, drought, storms, and wildfire. I love to show this graph and impress people, but of course you can already see it in your slides, so it's going to be less impressive. But back in the 1920s, on average, almost 500,000 people died each and every year from climate-related disasters like floods, drought, storms, and wildfire. This was very often huge floods of huge droughts or some combination of the two in China and India that just killed literally millions, certainly hundreds of thousands of people. These were enormous floods and droughts that we pretty much tackle today. So what has happened, contrary to what most people would think, is not that this number has gone up and up, but actually that it's gone dramatically down. So that today, every year, about 15,000 people die. Now, that's still too many. That's obviously 15,000 people we would like to save. But this is not a catastrophe escalating out of control. This is actually an issue where we have more and more control over this. Again, this has nothing to do with climate. This has everything to do with resilience and human technology. This is because we as a human race have become much better at predicting catastrophes, that we've become much better at preventing these catastrophes. To a very large extent, this is because people are richer. If you're lifted out of poverty, you're much less vulnerable, you're much more likely to not die in a flood or a drought or a storm or a wildfire. So again, this is all about human society adapting to these issues. But the crucial bit is, again, this does not tell us about a climate catastrophe. This, if anything, tells us that there is a huge success from human ability to handle climate. This, of course, is also what we see if you separate this out on individual areas, and if you do it for rich and poor countries, we see the same pattern for all of them. As you get richer, you get more secure. One way of looking at this is, if you look at flooding, flooding is one of those stories that we hear very often. As as temperatures rise, we're going to see rising sea levels. There's virtually no good thing about sea level rise. It's all negative, it's all costs. So as sea levels rise, 3 feet over the coming century, or about 1 meter, that will be a significant issue for all nations. And obviously for Tokyo, with many parts of Tokyo already at or below sea level, that will be a cost. That's a cost that we would rather avoid. But if you look at how many people are flooded, so if you look at this, this is one of the most highly quoted papers, which is why I'm showing it, even though it's a decade old, with lots of models and lots of estimates on how many people are flooded each and every year. This is a model estimate. And they found that in 2000, 3.4 million people were flooded each and every year on average. This had $11 billion in cost. These are all 2005 dollars, so they're inflation adjusted throughout the century. There's also a dike cost, or an adaptation cost, of about $13 billion per year. The total cost, so the 11 plus $13 billion in the year 2000, is about 0.05% of global GDP. So two things. Flooding is not the major part of the cost of GDP. It's 0.05, but it's still a significant cost. What will happen if we look at the worst case warming, the highest population, the highest GDP? This is just one of the many scenarios they all show the same thing, but I'm just going to show you one out of this. If we assume that there is no adaptation, which is typically what is done in a simple way, just simply say, sea levels rise about 1 meter, what happens? Well, everyone who lives within 1 meter of the ISO curves on land will be impacted. They will eventually have to move. And so you get this sort of outcome, that by the end of the century, because there's no adaptation, 187 million people will be flooded, or they will actually have to move, right? This has been a headline in New York Times and Washington Post and pretty much all other papers around the world. This is a result from original run from 2011, but it sort of keeps coming back. It was in the media just a couple of years ago again. This is a great story, right? 187 million people will have to move, or as Rolling Stones put it, they're going to drown. But of course, they're not going to drown. This is 80 years. You have a lot of time to move. But there's a real problem here. It's also going to be fantastically costly. It's going to cost $55 trillion each and every year in flood costs. Of course, the dike costs are not very high because we're not doing anything. So the total cost is going to be about 5.3% of GDP. Huge problem. It's also enormously misleading. The authors of this report and of these numbers very clearly state this is not going to happen because we're going to adapt like we've always done in human society. We know how to adapt. It's actually very, very cheap. It'll probably cost less than 0.1% for all nations, bar a few Pacific Island nations. Much less than 0.1% on average. So if we adapt, you see this curve instead, which is basically that nobody is going to get flooded by the end of the century. With adaptation, we estimate that about 15,000 people will be flooded. So instead of 3.4 million people, virtually nobody will get flooded. Now, this requires a lot of nations to actually do adaptation. For instance, the US is pretty bad at this, but eventually, of course, most nations will get around to doing that. It'll have higher flood costs, yes, because there's going to be a lot more stuff to flood. And there will also be much higher dike costs because you actually have to adapt your dikes. But overall, notice the cost has now diminished to 0.008% global GDP. We've actually seen a decline, dramatic decline in the total cost of flooding, despite the fact that we've seen a sea level rise of about 1 meter, because technology and adaptation means that the overall cost will be much less because you can protect many more. Now, what I haven't shown you, and I can't show you this diagram, is if we also did climate policy, we could reduce this further. So instead of 15,000 people, we could see just 10,000 people being flooded, which of course is great. But it's not the climate policy that will do the main part of the lifting. That's the adaptation part. The climate part is a nice little addition on top of it. So 5,000 people, of course, there's many other ways that you could save 5,000 people and probably much, much cheaper. What this overall tells you is that we hear a lot about the problems from climate change, but we fail to remember that adaptation will do a lot of the heavy lifting in the future. So again, climate change is not the end of the world. It's a problem. And that's an important part of the conversation. We only get this right if we understand it's not the end of the world, it's a problem. Then we're much more likely to get this right. So I told you before, I wanted to emphasize how this makes the world better, but slightly slower. So global warming doesn't mean the end of the world. It simply means that things get much better, slightly slower. Let me show you 2 ways of thinking about this. I would love if you have a good way to tell people this story, because I think this is the fundamental problem of getting climate change across to people. We don't do that very well because we don't know how to do this. Take a look at hunger deaths, for instance. We know that hunger deaths are related to climate change because as temperatures rise, we're going to see harder production of agricultural food. We'll probably see mostly higher prices of agricultural goods. So people can buy the same, but they'll have to come up with more money, which is going to be a problem, especially for poor people. We also have seen over the last couple of decades a dramatic decline in the number of people that actually die from malnutrition. This is the global burden of disease. And what you see is we used to have about 7 million kids dying from hunger-related causes in 1990. We estimate this will be about 500,000 by mid-century. But this is without global warming. So the World Health Organization has made an estimate. What happens if we have global warming? Well, we have a worse world. So there will be more people dying from malnutrition if there's climate change. But notice, even on the climate change path, the world still gets better. It just gets better slightly slower. And this is the crucial bit. The world will still be much better in 2050 than it was in 2030, or it is in 2024. But it will be slightly slower progress. That means instead of reaching the level in 2050 of hunger-related deaths, it may be 2055 before we get there. That's a problem. It's certainly something we'd avoid, but it's not the end of the world. It's a world that gets better slightly slower. The same thing with malaria. If you look at malaria, we've seen malaria used to kill lots of people around the world, and we mostly conquered it, partly because we got richer, partly because of adaptation, partly because of better drugs, but mostly because we fixed it almost everywhere except for Africa. But what you also see here is we expect, and this again, World Health Organization, we expect that malaria will get smaller and smaller burden. As people become richer, we can afford to treat our kids better, and we can afford to drain the marshes more so we have less malaria. But with global warming, we expect that there will be more places where mosquitoes can actually survive, and that will probably overall be a net problem for malaria. But again, if you look at this with climate change, yes, it's going to be worse, but not very much. So it again means it'll be better and better, but slightly slower. The second thing is, once we've gotten to understand that, yes, climate change is a problem, but it's not the end of the world, we can also now start thinking smartly about how should we react to this. So the current set of climate policies that we have are very much shaped from, this is the end of the world, so we need to do everything. But we end up doing very unrealistic and unsustainable, very costly policies. So one great example, I tweeted this recently, if you look at the EU and, by the way, Japan, electricity prices for households, enormously high compared to pretty much everyone else. I'm just showing the US and China, but if you look at my slide, this is from the EU in 2023. They're coming with an update later this year. I'd love to be able to see it after the Ukraine spike. But what it basically shows is we're making everyone much poorer than they otherwise need to be. And that, of course, is going to be very hard to sustain. This is another way to show this on, if you look at the share of global renewables. We think we're marching inevitably towards sort of 100% renewable, but actually we spent most of our lives getting rid of renewables. Remember, in 1800, the world was 94% renewable. It was basically just Britain that was using fossil fuels, and the rest of the world was almost entirely renewable. And for the last 200 years, we've spent getting rid of renewables, and we've been on about 13-14% renewables. That's mostly poor countries in the world using wood and dung and cardboard or whatever they can get their hands on to cook and keep warm. This little bit that we see in the 2010s and onwards, the slight increase, this is all climate related. Because we're spending lots of money on getting more renewables, we are getting more renewables, but only slightly. We've probably gone up to about 16% today. So we've achieved some things, and if we look out into the future, politicians will tell us we'll get to 100% by 2050 or even sooner and by 2030, which of course we won't at all. What we'll probably get to is, so this is the International Energy Agency, very optimistically believe it's 33%, and the Biden's Energy Information Administration believes it's going to be 26%. If you extrapolate this out, which is not realistic because I'm just going to use a linear extrapolation, but it actually looks like both of them are sort of curving off. But if you do that, the time to 100% is going to be 2153 for IEA and 2253 for EIA. So we're basically a century to 2 centuries away from what politicians are promising us. We're just not going to get renewable anytime soon. And so what I want us to start thinking about is to realize we cannot continue down this road that's going to be very costly and deliver fairly little on climate. We need to think about, are there smarter ways? And one crucial bit, and this is really not my idea, is just simply to recognize that climate means costly damages. Yes, we hear this constantly, but climate policy also means costly damages. We often forget this. And this, given that we have to pay both, we really have to find a way to minimize the sum of these two. This is essentially what Nordhaus got the Nobel Prize, the only climate economist to get the Nobel Prize in economics, what he got his Nobel Prize for, saying that they're both cost to climate and cost to climate policy. And we need to recognize both of these. So if we look at how much will this cost, if you look at on the temperature increase here, These are the estimates that Nordhaus did in 2017, and it's just been updated by Richard Tull for 2024. It gives pretty much the same impact. So if we estimate we'll get to somewhere between 3 and 4 degrees by the end of the century, the cost will be about negative 3 to 4% of GDP. Out here is percent of GDP per year, and out here is the temperature on the x-axis. What this tells us is it is going to be a problem. 3 or 4% is obviously a real cost. But again, it is not the end of the world. It's not near 100% or 100%, right? So again, remember, if you look out into 2100, the UN makes a lot of estimates of how rich are we going to be. This is just the middle of the road scenario I'm showing you. The middle of the road estimate that by the end of the century, the average person on the planet will be about 450% as rich as she or he is today. So we'll be much, much richer by the end of the century. Of course, Japan might only be twice as rich, and many people in developing countries will be much richer than 450% rich. But this is an average just for the world. If we look at what this means for climate, because clearly this doesn't take into account climate, actually what that means is instead of actually being 450% as rich, it will feel like we're only 434% as rich. And I'm putting the only in quotation marks because clearly this is still a much better world, but a slightly less much better world. And what that tells us again is climate change is a problem. It means that things get better, but slightly slower. The problem with the current set of policies is that they're fantastically costly and don't deliver. I'm just showing you one from the, this is a totally new estimate from last year from Climate Change Economics. Mendelsohn and company asked 10 teams of economists to model both the costs and the benefits. Most of them did not actually do that, but 2 teams did. We have 1 estimate of the benefits of a net zero policy and 3 estimates of the costs. Remember, this will be fantastically costly, but that's not necessarily a bad thing, because if you pay to get really good results or avoid really bad results, that might actually be worthwhile. But the annual benefit undiscounted over the 21st century from net zero turns out to be around $4.5 trillion a year. That's a lot of money, which of course is one of the reasons why we should take climate change seriously. But the cost of going net zero, and this is the average of all 3 estimates, turns out to be much higher at about $27 trillion per year. So spending $27 trillion to avoid $4.5 trillion of benefits is a bad deal for humanity. This does not mean that there's not a way to do this rightly, and that's what I'll then talk about very briefly. So if we actually want to do and tackle climate, how should we work? Well, we know that there are some things that don't work. So the EU 2020 climate policy, for instance, is an incredibly expensive way to achieve very little climate benefit. We estimate that for every dollar spent, we have avoided 3 cents of climate damage. That's a very bad deal. For every 100 yen that the EU spent, you avoided 3 yen of climate benefit, of climate damage. A very poor policy. What I just showed you with the net zero 1.5 degree policy, again, a very poor payback. It's slightly better because you get the poorer countries to do a lot more of the hard work. So we estimate about 17 cents back on the dollar, or 17 yen back for every 100 yen spent. But there are smart ways. For instance, a smart global carbon tax that starts out small and increases could be a good solution. This is what Nordhaus showed, that if you do this well, for every dollar spent, so it will have significant cost. It will drain some resources from the economy, and mostly it will slow down growth, but it will also slow down climate damages. And if you do it well, you can actually get $2 back for every dollar spent, or 1 yen, 2 yen back for every yen spent. This is going to be hard to do. A lot of politicians try to not do this. We rarely do this well, and very clearly it has no prospect in the US, but we also know that even in the EU, that is very climate friendly, it's very, very hard to get a political agreement on a consistent carbon tax. Instead, it ends up being 100 or 1,000 different carbon costs, depending on political constituency, and then the benefits are certainly much smaller. But the crucial bit that I want to leave you with in thinking about how do you deal with climate change is, by far the best thing to do is to focus on innovation. Fundamentally, all big problems that we've had as humankind, we have dealt with through innovation, not by telling everyone, I'm sorry, would you mind being a little poor, a little less comfortable, a little less prosperous, a little colder. That rarely works very well for people. But what does work is innovation. If you think about it, in Los Angeles in the 1950s, it was a terribly polluted place, mostly because of cars. Now, the sort of standard environmental approach would have been to tell everyone, would you mind walking instead? And of course, if you've ever been to Los Angeles, you know they would just have laughed at you. That would never have worked. What did work was the innovation of the catalytic converter. A little gizmo you put on the tailpipe, it cost a couple of $100, and then basically you can drive much longer and pollute much, much less. That's what mostly solved air pollution in Los Angeles. Not the only thing, and so I'm simplifying the story, but fundamentally, innovation is how you can allow people to have all the things they like and pay a little bit and then actually get all the benefits that we were trying to achieve. And that's why we find we work with some of the world's best climate economists to look at what are the smartest ways to deal with climate change. And this was the long-term best way to tackle climate change. What they came up with was, say, spend much more on green energy R&D. And the point is, you should spend it on fourth generation nuclear, you should spend it on batteries and solar, you should spend it on better geothermal, you should spend it on a lot of different things. So I don't know if you know Craig Venter, the guy who cracked the human genome back in 2000. He has this crazy idea of growing algae out on the ocean surface, and they would basically just soak up sunlight and produce oil. And then we harvest the oil out on the ocean surface, and we can continue our fossil fuel-driven economy, and it's all CO2 neutral because they just soaked up the sunlight a couple of months ago. All the CO2 out on the ocean surface. This, in principle, works. It doesn't work at all economically. But imagine if it could. We should give him a couple $1 million to figure it out. If it worked, we could solve this problem incredibly cheaply. Again, I'm not arguing that this is the right way. I think it's a fun story. But the point is, there are thousands of these ideas. Those are the ideas that could power the 21st century. We should just simply be funding them. And innovation, just like the catalytic converter in Los Angeles, is the way to make this work much, much cheaper. You know, if fourth generation nuclear, which is probably the easiest thing to imagine, if fourth generation nuclear really is so cheap and safe as they say it is, everyone will buy it. You don't need a Kyoto agreement or a Paris agreement. People will just buy it. The Chinese, the Indians, the Africans, everyone will buy it simply because it's cheaper. So the trick here is to get the innovations available to cut carbon emissions. So this is what works, not what we've been trying so far. But what I'd like to just end on with is to talk about some things that we rarely talk about when we're talking climate. Because everybody's so focused on saying, oh, it's all about cutting carbon emissions, which is part of the solution. But remember, there's another way to tackle climate, which is prosperity. Fundamentally, if you're richer, you're less likely to suffer badly from climate change. This is known all over the world. Most people who are vulnerable in the world is not rich Japanese or rich Danes. It's poor people in the developing countries. They are vulnerable to climate because when you're poor, you're vulnerable to everything. You're more vulnerable to diseases, to hunger, to everything else. And so if we can lift people out of poverty, they will be much better off. This is one of the Nobel laureates, Tom Schelling, that we work with, his conjecture back from the 1980s, where he said, is it actually better to help people, if we want to help them with climate, is it better to cut carbon emissions or to lift them out of poverty? Well, actually, both of these are true. And just to show you one of these things, remember, this is what the the scenarios that the UN climate panel has put forth. These are different ways, so different sort of main scenarios for the world. So regional rivalry, inequality, middle of the road, that was the one I showed you. This is per person income over the century. This is the 450% that I talked about. This is the sustainable development is what everybody's talking about we should get to. It's very optimistic, but we could actually make the world 600% as rich as it is today, each and every one of us, by the end of the century. That'd be a fantastic world. But I think one of the fun things that most people ignore is if we just stayed on our fossil fuel course, we could make people more than 10 times as rich as what they are today. Maybe that would be better for the world's poor. Well, but there's still a problem with climate change. Let me just share with you this. So if we look just on the sustainable development and the fossil fuel development, clearly the fossil fuel development is better off per person, but we didn't take into account climate change. But if we do, so with 3.2 degrees warming by the end of the century in the sustainable development, we should actually correct that's a 2.5% cost. So that means actually we're going to be this much richer. Still pretty damn decent, right? But remember, with the fossil fuel, it's going to be much, much higher warming. So there's going to be a much higher cost. But even if you include that cost, the fossil fuel development will still be much, much better, even when you've taken into account the cost of climate change. Again, my point here is not to say that we're not a smart world. We can do several things at one time. We can also do something about climate and do something about growth. But we should remember that growth is an incredibly important part of the story in lifting people out of poverty so that they can handle climate better. And of course, we should also recognize that there are many other problems beside global warming. Poverty, hunger, disease. If you ask what is the world's deadliest environmental problem, most people will tend to say today that it's global warming. They will be spectacularly wrong. If you look at how many people die from different diseases, so we estimate that indoor and outdoor air pollution is by far the biggest killer in the world. This is from global burden of disease. The deaths from global warming comes from the World Health Organization. And notice that the World Health Organization estimates that global warming will be more deadly by 2050. But still, by far the deadliest is indoor and outdoor air pollution. But of course, if you ask what's the world's deadliest problem, reasonably, the world's biggest problem is poverty. Now, remember, there's a lot of overlap in these definitions. In poverty is probably a lot of the pollution problems as well, and we can't separate them out. So this is mostly a sort of order of magnitude argument. We estimate that poverty kills about a third of everyone who dies in the world. Fundamentally because if you're poor, you die a lot. If you're rich, you die a lot less. Well, of course you still die eventually, but you live a lot longer. And if you ask most people around the world, so this is from the 2015 survey from the UN, what are the most important things that you would like the world to deal with? They told us very clearly it's education, health, jobs, corruption, and nutrition at the top. And actually, climate change came in at the very bottom. Again, it's not to say that for poor people, this is mostly poor people who answer, for poor people, yes, they would also like us to fix climate change, but they'd much rather ask us to fix education and health and these many other very simple problems. And so what we're working with, and what I just want to leave you with before I shut up, is that not just should we be talking about climate and how we deal with climate smartly, but we should also recognize there are many, many other things where we can help the world. And many of these policies will be much cheaper and much more effective. So we work with more than 100 of the world's top economists to look at where can you spend money and do the very most good. What they show us is that by far, this is an overview. You shouldn't actually read all of these. I'm just showing you this to impress you. But you know, this shows we did a very large study of all the biggest problems from the Sustainable Development Goals, the so-called SDGs. And what we did was cost-benefit analysis for each one of these. And so what these show is the longer the line, the bigger the bang for the buck, or the more return on investment. So we should really be looking at long lines for the world. We don't, but we should. And so what we've just been doing is, and this is my newest book, which is called Best Things First. I also have a copy of that here for you. We should think about where can we spend money to do the most good for every yen or for every dollar that we're spending. And so one of the things that we've identified is that there are 12 amazing policies where we could do an incredible amount of good for very little money. For instance, maternal and newborn health. I don't know if you know, but every year about 300,000 women die in childbirth. About 2.3 million kids die in their first 28 days on Earth. And we could save most of these at very low cost. We estimate for about $5 billion a year, so not nothing, but a fairly small cost. We could save 166,000 moms and 1.2 million kids of these newborns. For very little money, for every yen spent, we could do 87 yens of good, or for every dollar spent, we could do $87 of good. Likewise, tuberculosis. Tuberculosis used to kill a lot of people in Japan, as it did in most countries around the world. It was a tsunami of death in the 1800s. And then we found antibiotics. We fixed tuberculosis in the rich world, but we still need to fix this in much of the poor world. Again, for very little money, about $6.5 billion, we could save, in the long run, 1 million people per year. Or for every yen spent, we could do 46 yens worth of good, or for every dollar spent, we could do $46 worth of good. Education, huge problem. Most kids in the poorer part of the world are now in school, but they're learning virtually nothing. One good way of actually teaching is much better. There's a lot of ways you can spend a lot of money and achieve almost nothing. We've seen that in a lot of different policies. But one way you can actually, that we have very good randomized controlled trial studies for, is to get each kid in front of a tablet with educational software 1 hour a day. Now, don't give them the tablet, then they'll just play on it and watch movies, all that kind of stuff. Get them in front of this tablet 1 hour a day so they actually have to share it with a lot of other kids. If you do that for 1 year, this software, which is very widely available and been translated into many hundreds of languages, so it's very cheap to do. This computer program will essentially very quickly find out exactly where this kid is at and teach at her or his own level. So instead of being lost in a sea of many, many other students, this program will teach you at your exact level. So you do this 1 hour a day where you actually learn a lot, and then the other 7 hours you still go to school late. You don't really learn very much. We know for a fact that after 1 year of doing that, you will have learned as much as you normally would have spent 3 years learning. You simply triple the outcome of education quality. Now, remember, it's not very high in the first place, but tripling is incredibly good. So it costs about $31 per kid per year. But the benefit is that these kids become much more productive, so that over their lifetimes, they will make about $20,000 more in income. Now, of course, most of that is far into the future, so if you discount it back till today, it's about $2,000. But spend $31 to do $2,000 worth of good. That's an incredible deal. And so again, for every yen spent, you can do 65 yens of good. We have 12 of these ideas. So agricultural research and development, land tenure, skilled migration, e-procurement, trade, malaria, chronic disease, nutrition, childhood immunization. I'm just listing the problem areas. We have very specific interventions for each one of them. We can do an amazing amount of good. So we estimate the total cost of doing this would be about $35 billion. So not nothing, but in the big scheme of things, very, very small amount. And the total benefit would be, it would save 4.2 million lives each and every year, and it would make the poorer half of the world $1.1 trillion richer. This simply is the best things we can do. So again, what I wanted to say is, yes, climate change is a real problem. We're tackling it badly right now. We should tackle it smarter, and that's mostly about investing in green energy R&D. And then, of course, we should remember that there are many other problems we should also fix. And if we focus slightly less on climate change and we're slightly less scared about climate change, we're also better able to actually do the smart stuff on climate, on everything else. and this is what everything else looks like. Thank you.
はい、それではですね、私からですね、ビョルン・ロンボルグさんの講演資料を使ってですね、日本語で少し解説をしたいと思います。少しはしょりながらになりますけど、分かりやすくお話ししようと思います。まず最初そのタイトルですね、気候変動と効率の良い、効果のある政策ということで、アラーミズムですね、なんか恐怖を煽り立てるのをやめると、それから何兆ドルもですね、お金を使うのを無駄遣いするのをやめようと、そういうサブタイトルになっています。で、まずその地球温暖化っていうのは実際に起きてるし、それは人間が起こしてるんだよということですね。ただ問題はそれが非常に誇張されておるということでありますと。でこのグテーレスさんですね、国連の事務総長とか、大変だ大変だと、世界の終わりだというようなことをよくおっしゃるわけで、同じことを、アメリカのバイデン大統領とかもおっしゃるんですけども、本当かと。でそれはですね、統計見てみたらですね、これアメリカで上陸している台風の数ですけども、120年にわたって別に増えていませんと。でそれからアメリカに上陸している、これは大きな強い台風ですね、これも過去120年間増えていませんということで、メディアではですね、よく台風が来るたんびに問題だと、気候変動のせいだと取り上げるんですけど、そういうふうには実際はデータ見るとなってませんということです。で、山火事ですね、山火事もこれ映像的にはすごく映えるんで、気候変動のせいという話でよく報道されますけれども、ただこの世界でですね、どれだけの面積が燃えているかというと、1900年時点では 4% ぐらいだったんで、それが実は年々減ってきているわけです。でこれがですね、将来はどうなるかっていうのはこの右側にあるんですけれども、気候変動対策をしなければこの黒い線、これでもですね、実は山火事の面積は減り続けるという傾向には変わりはないわけです。でこれがですね、気候変動対策をやってあまり暑くならなければ少しは減るんだけれども、それほど大きくは減らないというのがこの緑色の線ということです。この山火事が減ってきている理由っていうのはですね、昔は山火事っていうのはよく起きていて、でそれはその後管理するようになってからだんだん減るようになってきたということです。でそれからですね、大事な問題としてその適用、このことがですねきちんと考慮されていないっていう話があります。でここでいう適用アダプテーションというのはどういうことかというと、CO2 の問題を考えるときにですね、その排出を減らすっていうことがミティゲーション、排出削減って言われるんですけど、アダプテーションっていうのは温暖化してしまったときにそれに対してですね、後から事後的に対策をして対策を打つこと、事後的に対策を打つことをアダプテーションって言います。適用って言います。で、これですね、その気候に関する死亡者数ということで、これはですね、世界全体ですけども、昔は毎年平均して何十万人、50万人とか多くの人が死んでいたというのが100年前と。だけどこれは激減してきました。ここで気候に関連する死亡っていうのは洪水とかですね、あと日照りとか台風とかそういったものですけども、でこれ非常に減少してきましたということが大事で、これは気候変動とはもちろん何の関係もなくてですね、洪水に対する備えっていうのは例えば堤防を作るようになったとか、そういう技術が進歩して経済が発展してそういう投資がなされたということが大事で、そういったことをですね、防災の対策を打つことをここでは適用って言ってますけども、それが非常に大事だということです。で、洪水に関する見通しとしてはですね、これ100年後の見通しとして洪水が非常に増えてですね、1億8700万人の人が洪水に遭うんだっていう、こういう予測があって、これがメディアでも随分話題になったんですけれども、ただこれはですね、堤防を強くするとかそういうことを一切考えていない話であると。できちんとですね、その堤防などに投資をすると、この下のですね水色の方になって、今よりもですねむしろ洪水に遭う人の数は激減するということであります。というわけできちんと 堤防とかですね建設することに投資するその適用ということをやれば、実は今よりも随分状態は良くなるので、気候変動があるないということよりもきちんと防災の投資をすると、そちらの方が大事だということです。で大事なことはですね、この気候変動っていうのは世界の終わりではないと、一つの問題ではありますということです。でこれも非常に面白い言い方なんですけど、気候変動世界の終わりではなくて、どういうことかってもう少し正確に言うと、物事は大体今よりもはるかに良くなるんですと、それがほんの少しだけ遅くなるっていうのがその気候変動ということですというわけです。でこれはですね、飢えによる死亡者ですけども、これも世界全体で見ると数はずっとですね過去40年ぐらい激減してきたと。でこれが今後ですねやっぱり激減していくことは間違いないと。でそれがですね気候変動がある場合とない場合というのはこの青い線と赤い線なんですけども、気候変動がなければそれだけ飢え死にする人が減るんですけれども、ほとんど実は変わりはありませんということであります。でそれからマラリアによる死亡者数ですけれども、これもですね過去100年以上にわたって激減してきたわけです。これは衛生状態が良くなってきたからです。でそれがですね今後40年ぐらいやっぱりその気候変動対策をやった方が少しは減るんですけれども、もうほとんど線が重なっているぐらいでですね、ここで大事なのはやっぱりこれまで通り衛生とか医療の対策を続けることであって、で気候変動っていうのはそれをほんの少し変えるかもしれないけど、大きな傾向を変えるものではないということです。でそういう目でですね、今の気候変動対策というものを見てみると、非現実的であって、しかも持続不可能なものになっていると。でなぜならその電気代はですね、日本でもヨーロッパでもアメリカでも非常に上がってしまっていると。でそれから再生可能エネルギーを2050年にですね、100% にするとかいう目標を出しているところもありますが、実際のところはそれには程遠いと。実は再生可能エネルギーのシェアっていうのは1800年には90% 以上だったと。それを化石燃料などで置き換えてきたんですけども、でそれを今また再生可能エネルギー増やそうとしてるんですが、かなり野心的なですね IEA の目標でも、100% には程遠いと。それからアメリカのもっと現実的な見通し EIA というやつですと、もっと再生可能エネルギーの導入はゆっくりだろうということです。でじゃあもっと賢いですね気候変動対策というものはどういうことか。それはですね、認識としてはその気候変動も悪影響があるかもしれないけれども、それへの対策としての気候変動政策ですね、そっちの方もとんでもないコストになるかもしれませんということです。で気候変動のですね影響っていうのは気温の上昇あたり GDP の何%ぐらいあるか、これいろんな研究レビューしたものなんですけども、2度3度上がるとですね GDP が2、3% 失われるという見通しがあると。でこれは大きなコストなんですけれども、ただこれもですね、コンテクストが大事で、今後100年ですね中間的な見通しでも世界の所得っていうのは平均で 4.5 倍になるというふうに見られていますと。で気候変動が起こるとですね、これがほんの少し減ると。さっきGDP が結構減りますという絵になってたけれども、実はこの 450% に所得が増える代わりに 434% になりますというぐらいのことで、全般としては圧倒的に物事良くなるんだけど、それが少しだけ遅くなるということです。で2050年までのですねこのコストとベネフィットっていう言い方をしますけども、気候変動対策のためのお金と、でそれによって避けられる被害のことをベネフィット、便益って呼んでますけども、それはですね、便益よりもコストの方が圧倒的に多くなるという試算になっています。でそれからですね、ということでですね、どうしたらもっと賢く気候変動問題に対処できるかということで、これまたベネフィットですね、同じ1ドルのお金を使ってそれでどれだけの便益があるか、気候変動の被害をどれだけ軽減できるかということを調べると、CO2 をゼロにするというような政策は非常に効率が悪いと。 でここでですね一番推奨しているのはグリーンエネルギーイノベーションということで、イノベーションにきちんと投資をすれば効率的な気候変動対策になるということです。で所得を向上させるということが非常に大事だよということで、所得が向上すればですね、たとえ気候が変動してもそれほどひどい目に遭いませんということで、一つ面白い点がですね、これ将来の所得の見通しをいろんなシナリオ別にですね調べたもの、IPCC のものなんですけど、21世紀のですね、持続可能な開発って言って、CO2 を大変に下げるようなやり方をしても、この所得が 600% になるというふうに予測しているわけです。100年間で 6倍になると。ところがですね、別のシナリオを見ると、化石燃料をひたすら使ってですね、いくシナリオ、これの経済成長率が高くなっていて、所得がですね、その 1040% になっていると。で、そうすると、こっちの方がむしろいい世界だと言えるのではないですかということですね。で、これは気候変動に関してですね、悪影響を受けるといっても、それほど大きいわけではないですから、結局大きな絵としては変わらなくて、その化石燃料をたくさん使った開発の方が実は世界の所得ははるかに高くて、人は幸せになるということです。で、最後にですね、この問題っていうのは気候変動以外にもたくさんあるよということなんですが、この辺はですね、WHO の調査ですけども、環境問題の中で本当に大事なのは何かというと、今でも世界では大気汚染とかそういう問題の方が大きくて、地球温暖化ではないと。でそれから環境問題に限らずですね、何が一番問題かというと、まだこれはやっぱり貧困といった問題の方が重要である。で温暖化というのはそれに比べれば重要ではないと。でそれからこれは世界中でですね、970万人に調査したっていう投票なんですけども、これも何が世界で一番大事かという投票ですけども、教育や健康、そういったことの方が気候変動より大事だというふうな投票結果になっていますということです。でもっとですね気候変動以外にたくさんやらなきゃいけないことがあるっていう話なんですが、これはSDGs のですねたくさんある項目の中で、その費用便益分析ですね、やった結果どうかっていうことなんですけど、気候変動対策っていうのは非常に費用対効果の悪いものだと。費用と便益を見比べた場合に費用がかかる割に便益が少ないものだというような結果になっていますと。でこれがその要約ですけども、同じ1ドルを使うのでですね、母子の健康のために使えば87ドル分の便益がありますと、87倍の便益がありますと。それから結核の胎児のためにですね1ドル使えば46ドルの便益がありますと。教育に使えば65ドルの便益がありますということです。でこのプレゼンの途中出てきましたけども、気候変動に対してですね CO2 を2050年ゼロということをやっても1ドルあたり0. いくらかしか便益はありませんということなんで、こういったことにもっとお金を使った方がいいだろうと。気候変動は存在するんだけれども、それほどですね破滅的な地球の終わりというわけではなくて、その経済成長が少し遅くなる、いいことがたくさん起きるのが少し遅くなるということと、それから同じ気候変動対策をやるのであればイノベーションに投資するのが一番費用対効果がいいですということと、それから気候変動にばかりですねお金を使うよりはもっと大事なこと、費用対便益の効果の大きいものもたくさんありますと、そういったメッセージだったと思います。どうもご清聴ありがとうございました。はい、ここからはですね Q&A セッションということで、まずですね紙ベースで質問を寄せていただいた方の方から始めたいと思います。最初がですね気候変動、地球温暖化とそれから大気汚染っていうの実は結びついていて、気候変動のせいでその大気汚染がひどくなってるんじゃないかという質問です。Is the air pollution and global warming related? Some air pollution may be getting worse due to global warming.
So there is some overlap, yes, but the vast amount of air pollution problem comes from air pollution. So again, there's definitely, if you phase out fossil fuels, you will have less air pollution, at least from electricity generation. Again, remember, for instance, if you get more electric cars because they're heavier, we actually estimate that there will be more particulate air pollution. So, it's not an easy game, but overall air pollution is a separate problem. If you want to fix air pollution in China, it's about getting scrubbers on their power plants more than anything else.
Okay. 温暖化のせいで気候変動が大気汚染が悪化するということは少しはあるけれども、基本的には大気汚染は大気汚染で、それ自体の問題であるということです。The next question is you say that investing in green technology innovation is a promising way, but the innovation is always extremely uncertain. Is it worth doing it? すいません、日本語で言うの忘れてた。気候変動対策としてそのイノベーションに投資するのが一番いいとおっしゃったんですけれども、どうなるかわからない不確実なものだと、それに投資する価値はあるのかということです。
So it's uncertain, absolutely. And this is one of the reasons why a lot of people feel like, but I want to be certain. If we just cut carbon emissions, we're certain that we will tackle global warming. But of course, remember, just saying you want to cut carbon emissions doesn't make it happen. And it's very clear that the world is very uncertain if you can actually push through these policies. So all of the policies that we're doing will be uncertain. But what is certain is if you spend a lot more money on research and development into green energy, you're likely to get breakthroughs. Do we know that those breakthroughs will lead us to absolutely decarbonize? No. But we think that there's a much improved chance that we will actually do so. If we continue on our current path, it looks likely that we will achieve fairly little. Remember, we still haven't decarbonized. We have merely slowed the growth, if you will, in emission increases. It looks very unlikely that we will be able to do so. And certainly on our current path, we're making policies so expensive that people increasingly are led to want to vote for people like Donald Trump or other people who will eventually say, no, I'm not going to do any of this, for a lot of wrong reasons. But the main point here, again, remains, it is not such that there's an easy path that is the one that we're taking right now, and a difficult path that we're not quite certain on. I would argue that it's very unlikely that we are in the current path will actually achieve our goals, whereas it's much more likely that we will do so with energy innovation, but nothing is guaranteed. So if you want to put it very bluntly, I think our current policy success is perhaps 10% or less, whereas this perhaps has 90% or more, but it's not 100%, but I'd take 90% over 10 every day of success.
イノベーションへの投資っていうのはもちろん不確実なんですけれども、そうは言ってもじゃあこれで確実に CO2 が減る投資っていうのをやってですね、それは非常にコストがかかると、それがずっと継続するかどうかっていうそっちの方の不確実性も非常に大きいんじゃないかというのが主なご回答ですね。で、あまりこのコストがかかりすぎることをやると結局もうみんなそれはやめようというような話になってしまうと。はい。短くするとそういう答えになります。There are several other questions. Can you answer rather shortly?
Oh, okay, yes.
The statistics are open to everyone regarding your presentation, but still the media is talking about totally different story. Why they can do it? Why is it possible at all? Is there any manipulation of the data, or what is their tactics? 日本語で言うの忘れてた。統計データがいろいろ公開されててですね、こうやって見せればですね、いろいろ災害激甚化なんかしてませんということははっきりしているのに、なぜ報道では全然違うことが出てくるのかという質問です。
So I think there's very little manipulation, but there's a lot of selective reporting. So if you report on every climate catastrophe that happens, you're more inclined to believe, well, there must be a lot of them. But again, remember, you show more heat waves happening, which is absolutely true. That's what we would expect. In a warming world, you'll see more heat waves. But you very rarely see reporting of fewer cold waves, because that will also happen. And of course, remember, about 9 times more people die from cold than heat globally, and this is true in almost all countries around the world. But not something not happening is not a news story. You don't report, oh, nobody died from coal here, or that there's not a fire here. So you only report on all the things that happen, but the cumulative effect is that you think more and more extreme weather is happening, whereas what is really the case is some extreme measures, like more rain and more heat waves, absolutely true. Fewer cold waves is also absolutely true, but we rarely report it. We rarely report on a lot of other facts, and so it's more selective reporting. I think that's the problem.
データを操作するとか捏造するってことはあんまりないんだけれども、報道の仕方がすごく偏っていてつまみ食いになっているということで、例えば暑い日はすごく増えているって、それは一生懸命報道されるんだけど、実は寒い日が減っているっていう方がちっとも報道されていないと。で実際は暑さで亡くなる人より寒さで亡くなる人の方が圧倒的に多いわけで、その寒さが寒い日が減っているっていうのはいいニュースのはずなんだけど、そういうのは報道されていないと。そういう、データを捏造したり操作したりするというのではなくて、非常に選択的に報道されているということです。で、その次です。2100年まで化石燃料があるとして、その後なくなるかもしれない。その後何を使ったらいいでしょうか、という質問で。Well, up to 2100 there may be enough fossil fuels, but if it depletes, then what might be the next energy?
So it seems very unlikely on current paths that we would continue to rely on fossil fuels into the 22nd century for a lot of reasons. Partly for air pollution reasons, partly for climate reasons. We will undoubtedly find a different source of energy. So I would be surprised if we would be relying on fossil fuels in the 22nd century. What is going to be the technology? I don't think I know, but I don't think anyone really knows. And that's, of course, why we should be investing in all kinds of different opportunities. It could be fourth generation nuclear. It's sort of the easiest to imagine, and we should certainly be spending money on it. One of the things that I personally like best, but that's just because it sounds good, is the geothermal, because it's baseload power, and with fracking technology, we're actually much better able to dig the wells that can actually make it possible. But again, it's not cost effective now, but we should try to make it cost effective. So there are lots of different opportunities. We should not have politicians pick a winner. We should be funding all of them on research and development because it's so cheap, so that we can find some things that will actually be so cheap everyone will buy them.
2100年まで化石燃料ばかり使うようになるとはあまり思ってないと。大気汚染の問題とか CO2 の問題とかがあるんで、それほど化石燃料だらけにはならないだろうと。でその後ですね、じゃあどういう技術が出てくるかというと、それは分かりませんと。分かりませんけど、第4世代と言われる新しい世代の原子力発電っていうのが、個人的には一番あるんじゃないかと思っていると。ただ大事なことはいろんなテクノロジーがあるということで、その中に今は高いものもあるんですけど、それ安くなるかもしれないとか、幅広くいろんな技術に投資をすることが技術開発にですね、イノベーションに投資をすることが大事だと思うということです。山火事の面積っていうのは温暖化の指標になるんだろうかと。燃料が山に溜まっててですね、そうすれば燃えてしまって、それ自然の摂理だし、それから人間が火を湿火で出すということも増えていたりするということです。Is the area burnt by wildfire a good index of the global warming at all? If the woods are accumulated in the forestry, then of course it is quite natural that they are about to burn someday. And then the reason for the burning might be man-made. I mean, that maybe just a mistake or the sort of accidents.
Yes. So fire area is only one of the statistics you should look at. This is the only one that we have good data for a very long time. And very clearly, it is one important indicator because it tells you how much fire were we vulnerable to in the past and now. But it's very clear that, so for instance, in forest, a lot of people think that there is less forest. Actually, we know from satellites there's probably more forest since 1986 at least. And despite the fact that there are more forests, we see less burnt area. But again, remember, most fires not in forests. Most fires are in savanna. And so a very large part of this is because the vegetation structure in Africa has changed, because Africa is the most burning continent. It's also, to a very large extent, because people don't want fires. This is why we've seen a dramatic reduction, because you have more agriculture, and agriculture is valuable, so you protect it from fires. Farmers have an interest in making sure it doesn't burn. You're also right that there's probably more willful fire, and we used to slash and burn a lot. We do that less. This is not just about climate change. It's simply an indicator that you see more and more fire in the news, and that's certainly true from 2000 to 2023. But what we see in the satellite period is simultaneously a dramatic decline. And so again, this shows you a little bit like when we talk about violent crime. You see more and more of it on TV, but actually there's less and less. But this doesn't tell you anything except for the fact that we're seeing more and more selective reporting.
はい、山火事の面積がその温暖化の指標だというわけではないというのはそういうことであって、で、おっしゃるようにですね、人為的な要因というのは非常に大きいとで、特にサバンナでの山火事の面積というのは非常に多いそうなんですけども、アフリカのですね。でそこで山火事が減ってきている理由っていうのは、みんな農業をやるためにはその山火事になったら作物が失われるから、それで対策をして山火事が減っていると。それからスラッシュ&バーンだから焼き畑農業ですね、それもやらなくなってきているので、それも森林火災が減っている理由の一つでありますと。でそれで森林火災の面積どんどん減っていると。で森林の面積自体は増えてるんですけど、森林火災の面積は減っていて、でそうなんだけれども、山火事が起きるとですね、派手にニュースにするということで、そこはやっぱり情報を選択的に報道しているっていうバイアスがかかっているということです。Next question. Very good question indeed. すごくいい質問です。彼デンマークから来てるんです。デンマークは電気料金が世界一高い。国民や産業は幸せなのかっていう。Denmark is known as the country in which the electric tariff is extremely high. And perhaps the best among the world.
The highest, yes. I don't think best is the right word there.
Are you happy with that? Is your industry happy with that?
So I should just say I moved to Sweden, but not because of the electricity cost. It's pretty high there too. So no, of course, nobody likes high electricity costs. And it's one of the things that are going to make it very hard for most consumers to switch to electric power. So for instance, with an electric car, it actually makes your electric car a lot more expensive. What this shows us is you're not going to solve climate change by making everything more expensive, by making people poor, by saying you have to heat less in the winter, you have to cool less in the summer, and so on. What you need to do is to find innovation that actually means that your energy becomes cheaper. So we're going about this not only in the wrong way in the sense of realizing this is going to cost a lot of money, but also by actually disincentivizing the very things that should decarbonize us.
I mean, EV.
For instance, EVs, yes. Yeah.
電気料金が高くてみんなそれはもちろん不満ですと。で問題なのは電気自動車もですね、電気料金が高いからみんな買わないと。その電気料金が高いっていうことで実はその温暖化対策に逆行しちゃってますよというようなことが起きるということであります。それから最後ですね。Another question.
Another good one.
I don't know if it is a good one. 気候変動に悲観的な見通しをですね発表し続けているのがドイツにポツダム気候影響研究所っていうのがあるんですけど、これは一体まともな組織なので。
It's always worrying when everybody's laughing. So okay, let's go.
There is an organization called the Potsdam Institute for Klimaforschung.
Yeah, climate research.
Potsdam Climate Research
Yes.
Institute in Germany.
Yes.
Is always publishing very, very pessimistic
Yes.
future forecast.
Yes.
Is it the good organization?
I don't know enough about them, but they actually, I don't know if you saw, they were just in the news for publishing that climate change by 2050 would cost the world 19% of GDP. Yeah, so it was a big news story. Guardian, not surprisingly, and everybody else ran this. And it's based on a model that assumes that not just, so the thing I showed you, which is what Nordhaus, the only climate economist to win the Nobel Prize, what most climate economists tell you is that as temperatures rise, you're going to have a stepwise cost. But what they assume is it's also going to affect the growth rate of the country. So as you get hotter, your growth rate goes down. And so the typical argument is that very cold countries grow very slowly because it's very cold. Very warm countries grow slowly because it's very warm. And there's an optimum, which, by the way, is close to where Japan is, and many rich countries. It's sort of climate determinism. There is very little evidence that this is true. There's a lot of evidence that seems to indicate it's wrong, but it gives a very, very great answer, namely that climate change becomes incredibly costly. They misattribute it, and actually there's several papers out there that shows if you do this, it is more likely that we're going to become very rich than very poor. But most economists just simply don't believe this. But the crucial bit is to think about this. If you actually take this serious, what happens is that the countries that are very cold in the world will get warmer and hence grow the most. And it turns out that the two countries that are going to win in the world is actually going to be Iceland, which is going to be the single richest country in the world in 2100, and Mongolia, which of course is also going to be very, very much richer than the US is today by the end of the century. If you think that's true, then go ahead and believe all the rest of the stuff. If you think this sounds fishy, which I think it's very obvious it does, it's designed to make you scared. I think these people probably believe it, but as one of the most quoted climate economists put it a couple of days ago on Twitter, he said, this was published in Nature magazine, which has published several other bad economics pieces. And what he said, this is why economics should be published in economics journals. And it would never have been accepted in an economics journal.
とても長い答えだったんですけど、そのポツダム研究所自体がいい組織かどうかっていうのはそれはお答えしませんが、このちょうどですね、その1週間ぐらい前かな、新しいレポートっていうのが出てかなりメディアで話題になったんですね。それがネイチャーに出てきたんですけども、2050年に気候変動の悪影響っていうのは GDP の世界ですね、 GDP の 19% に上るっていうものすごいセンセーショナルな数字で、だけどそれでやってることを見てみるとどうもまともなことやってるとは思えないと。経済成長率っていうのがですね、気温で決まっていて、それが暑すぎてもダメで寒すぎてもダメでなんか最適な気温があるっていうんですけど、その理屈で彼らの計算っていうのは2100年にはですね、アイスランドとモンゴルが世界一豊かな国になるとか言ってるんですが、そういったことを聞いて皆さんどう思いますかと。私は信じませんと。で、こういう経済分析っていうのはもっときちんとした経済分析のジャーナルに出すべきで、ネイチャーっていうのはそういうものをきちんと扱うところではないということだと思います。